Hey, it's Tom, and today we're going to talk about face and face landmark detection on iOS. In the first part of this video, I will show you how to detect face on still images, and in the second part, we will go into live feed, just like you see right now. Okay, so let's jump to the code. Let's start with still images. So in this app, I created a simple app structure which contains two view controllers. The first one is for still images and the second for live feed. So let's start with still image view controller. So that's a very simple view controller which contains only image view, which takes the whole safe area. And it's important to set the content mode to the scale type to be aspect fit. However, that's currently the default one in Xcode 12 because I'm using the Xcode beta because I'm playing with beta on my own, on my phone. Okay, so that's it. And right now we can switch to still image view controller and let me explain you how it's working. So this is just an IB outlet for the image view. We need the scaled image rect because we provide the image. Let me show you what is the image. So we are providing a square image with my profile photo, and we need to know what's the exact size of this photo after being scaled in this image view controller. This scaled image rect will contain this size. In view did appear, we just set the image to be presented in the image view, and then we get a core graphics image because that contains all the metadata and gives us a lot more information about the image than just the raw UI image. So when we set the image, we call the calculate scaled image rect, and this method is responsible for calculating the origin and the size of the image in the UI image view, because when we provide the image to Vision framework, the data returned will be in a different format than we have, and we provide only the image. So Vision framework doesn't really know what's the position of this image in UI image view. So let me maybe show you how it's exactly looking on the phone. Let's run the app. We press still image, and as you see, we just present the image view. And this calculate scaled image rect calculates the data for us. So we get the original width and height, and then get the frame of the image view. And according to the aspect fit way of scaling, we are able to find out what has to be the width or height ratio of dividing the size. Then we know that with aspect fit, we just fit the image into the image view frame. So we have to get the maximum ratio because that will be the one used to scale the image both horizontally and vertically. And then we get the scaled image height and width, and then we can count the origin of this image view. So in our case, the X origin is of course 0 because frame is a rectangle, it's a vertical rectangle, so square will be put in exactly in the middle of this frame, and will fulfill the whole horizontal space. And in case of the Y axis, it will be somewhere in the middle. So we have to subtract the image height from the image view frame height, and then divide into 2 because it's always put in the middle. And that's why, and that's how we calculate the scaled image rect. Okay, so right now we have our image view that is presenting our UI image, and then we also calculated the exact position of the image in the UI image view frame. So it's time to send this UI image to Vision framework and ask for detecting face. So to do this, I prepared another method. called perform vision request, and the parameter that we are providing there is, sorry for that, okay, is our core graphics image, because it contains just more data than our UI image. Okay, let's jump to this method. It's not so big, so I'll hope I will be able to explain it to you. So at first we have to create a vision detect request, and there are multiple types of those requests. As you might see, give me a moment. We can request for multiple things like barcodes, contours, rectangles, face rectangles, and face landmarks. But in this case, detecting on still images, we will just focus on face rectangle, and then I will show you how to detect face landmarks in live feed, because I just don't want to explain the same code twice, and you also might be not interested in listening the same thing twice. Okay, so we create a vision detect face rectangles request, and we provide a completion handler. Important thing to remember is that to save time and be more efficient, we can group those requests. So we can send a multiple requests at once, because we just put those requests in an array and then call the vision framework to proceed them, and it will use multiple cores of the processor to handle them. So let's go through this method at first. So we create the vision detect face rectangles request. We create an array with requests. However, in our case, it contains only one request. And then we also create a image request handler, which will be used to call the array of requests from Vision Framework. And it's also important to call this code asynchronously to not block the UI main thread, to still keep the app responsible. Okay, so we send the request to the Vision Framework, a couple milliseconds passed, and then our completion handler is being called. And this is this is the very important part for us, and this is the last method in this UI view controller, so it's not very sophisticated code. Okay, so at first we ensure that there's no error, and then we also ensure that we already counted the scaled image rect, and then we get the image width and image height, because it's just easier to create constants than asking image rect .size .height or width every single time. And then we will create an overlay over the our UI image view, so we have to call this code in main thread. So in case we just called this code previously, let's remove all the sublayers from our UI image view, and then this is what we get from the Vision Framework. So Vision Framework returns us so-called results, and results is an array of vision. In our case, it's face observation. If we are calling different requests, we have to also handle different types like VN barcode observations. Okay, so right here, we just ensure that the returned results array is not nil, and we can handle that. Okay, so right here we have a for loop that is going through all the results returned from the Vision Framework, and each observation is just a vision face observation object. And now this is the tricky part, because in iOS, in UIKit, our starting point in any frame in any view is the top left corner, and the vision observations are being returned in a different orientation environment. So their starting point is in the bottom left corner of the object that was provided. So when we provide a photo, we normally treat it like the top left corner is 0, 0, and bottom right corner is max width, max height. And the results returned from Vision Framework are that the 0, 0 point is in the bottom left corner, and the maxed width and maxed height is the top right corner. So it's just the opposite. We would have to flip the result. And another thing which is important is that the result contains the bounding box with in a range of 0, 0 to 1.0. So it's just a scaled result. So because of that, we can actually observation bounding box. Okay, maybe let's call it right now, and you'll see what I'm talking about, and it will be much easier to understand it. Okay, yeah, so there are some errors. Anyway, this is the because it has only one result. There is just one print, and as you see, the result says that the bounding box is this is the starting x point, starting y point. This is the width, and this is the height. So we see that square. So the width and height of this detected face is 0.56 of the height or of the width of the whole image. So we have to just multiply the width and height with the image width and height. And in case of x, that's also not so bad because we are still starting from the left side. So in the case of x point, we just need to add the origin x of the image to know where it starts, and then just multiply the image width and the and this part returned from the Vision Framework. So it's 0.23 multiplied by, like, I don't know, 375 or something like that, the width of the image. And the tricky part, the most tricky part, is the on the y-axis, because the returned result says that the bounding box starts on 0.16 in 0.16 of the whole height of the image. But we have to remember that we are now working in a different coordination system, so we are counting from the bottom, and because of that, of course, to find the starting point of the detected bounding box, we have to start with the origin of the image, and then we have to remember that it's counted from the bottom. So the best way to find out the starting point in the normal UIKit coordination system is just to use 1, which is the whole height of the image, then subtract the observation bounding box, because that's the 0.16, so we are still in 0.84, something like that. And then we have to also subtract the height of the bounding box, because when we are subtracting from the bottom and we are counting from the bottom and we want to start counting from the top, we also have to subtract the height of the bounding box. And then, of course, multiply that by the normal image height. Okay, so we finally have our observation rectangle. So we create a core graphics path to be drawn on the newly created layer, and then we just create a layer, add this path, set that it will be transparent, set the stroke color to be like yellow. It looks pretty good. And then we just have to add this finally this layer to the UI image view. And as you see, the final result will be seen right here. And yeah, looks like the face was detected. And we are done with this part. Okay, let's now switch into the live feed. So for this case, I created a different view controller, which is just empty. It contains only the view that was initially added in the storyboard. So it's called live feed view controller. And let me go through this code to explain you how it's working. So right here we have view the load, and then we call the setup camera method. Setup camera method is a method that is using AV foundation to just discover the built-in camera. We are using the front camera as we provide this parameter here, and we start here the device discovery session. We just have to ensure that there is the real device available in the system, because that's all, of course, not working in the simulator. And then if there is a device, then we get it from the discovery session and we add it to our capture session. And capture session is AV capture session, which is an object which is available to handle the stream which is coming from the camera, either front or back camera. We can also provide a stream from a different source, but in our case we are just needing the buffer and the stream from the front camera. And right here we create a preview layer which we will use to add to our view to be able to see what's going on. So when we set up the camera, we call the setup preview, and setup preview is a method that is responsible for adding this preview layer to our existing view and setting up all the details about the video data output and sample buffer. So right here we just set the type of resize and the frame for the preview layer, and then we create a video data output which will be used to provide it to the capture session, as you see. And then we create a video connection object, get from the video data output, to set the orientation for portrait, because if we want to handle rotation of the iPhone, it will demand much more code. Okay, so we called those two methods, and let's see how it's working right now. Okay, we have the app, and yeah, we have the live feed, and as you see, there is my boom mic, which you usually don't see. You probably never have seen that. And the preview is working pretty fine. The whole view controller frame is filled with the video from the camera. Okay, this is what we needed. And right now we have to use this feed to provide it to the vision framework and then get our face detection rectangle, right? Okay, so we have the capture output method, which is the AV capture video data output sample buffer delegate method. So we set the delegate somewhere here, as far as I remember. Yeah, we set it here, and every time a frame is received from the buffer, this method will be called. So in this method, we just want to ensure that the image buffer is available, is existing, and then we just have to create vision detect request, as we have done that in the still image view controller. As you see, we create a face landmarks request right here, because we do not only need a face rectangle, but we would also like to get the face landmarks. And the rest looks exactly like in a previous example, with some small details, but we provide the completion handler that is not a separated method. In this case, we just put it in line. So we have the request and error, and this method has to be called on the main thread, because we just want to add some additional layers, and that's why we have to call it on main thread. So we have the face layers, and face layers is an array of CA shape layer that we will be just adding to our current feed and removing at each frame coming. And each face layer will contain different face rectangle or face landmark, because it's just easier to draw them on a separate layers, and CA layers are optimized to be quickly added and deleted from the preview. So that's the best way to handle that. So at first we just want to remove all the old face layers, and then, as in the previous case, we just want to get the observations, and then we'll handle those observations. So this is how we handle the vision detect face landmark request. But before we will be able to handle that, we have to create a request handler, and we have to remember that we are using the front camera, and we have to add the orientation that it's left mirrored, because front camera of the phone works exactly like a mirror, so you're flipped, and if you won't provide this parameter, your rectangle box will be always moved to the left. However, it will be correct in case of size, and even the landmarks will be correctly positioned within the rectangle. However, you won't be able to put that in a correct position. So it's always worth to remember that when dealing with front camera, the image is flipped. Okay, and right here we just provide the array of the requests. In our case, it's just one request, and the vision framework handles that all. And yeah, so we finally got our result. We deleted all the layers, and then for those observations, we just want to call the handle face detection observations method. And the good part right here is that as in previous case, we will just go in the loop through all observations, but we don't have to manually calculate the bounding box and add, subtract, multiply, and so on. We can simply just call the layer rect converted method on our preview layer, because our preview layer is AV capture video preview layer. It's not a UI image view, so it contains a very helpful method called layer rect converted, and face rect converted is already a proper bounding box that we can use to draw on an overlay and put exactly on the live feed, and it will just work as it should. So okay, let's maybe start the current code, and let's see how it's behaving. Okay, we have our app on place, and as you see, the bounding box is tracking my face pretty correctly. So it looks even easier than still images. Okay, so as I mentioned, it might be also interesting for us to get the face landmarks to detect also eyes, mouth, nose, and eyebrows, and so on. Okay, anyway, the good thing is that landmarks are pretty easy to be handled. So maybe let's start with just one of them, and then we'll just uncomment that. It will be just easier to explain. So let's start with, for example, left eye. Our observation, if we are using, of course, the VN detect face landmark request, contains also an array of landmarks. It's just an enum, and we can get each of them separately. And in our case, we want to start with the left eye. So we have a left eye, and this is vision face landmark region 2D. And then we want to handle that. We just want to create another layer to draw it and put on our live feed. Important thing to remember is that the coordinates of this landmark are according to not to the live feed, but to the rectangle of the detected face. So if you want to count those points using the live feed, you might find it like really weird, but you have to provide the face bounding box, and that will be the width and height that have to be used to find those points. So we create a new core graphics path, which is mutable, and we just want to get the eye normalized points, and each of those points have to be mapped, because as I mentioned, we just have to multiply them by the face bounding box width and height, and also add face bounding box origins. This is more similar to converting points in still images, where we have to manually count each point, because as in case of the vision framework, the result of face landmarks is just from 0 to 1.0, and we have to multiply that to find out where exactly it is. So then we use those all landmark path points to draw lines between them, close the path, and then just create a green layer to be added to our face layers, and to be added also to our live view. So let's call this code, and hopefully right now, yeah, as you see, my left eye was detected. And if we will uncomment all other landmarks, you will see that a lot more parts of my face will be detected in the app. And yeah, looks like it's working. And it's working pretty cool. Yeah, okay. Oh, that's everything I prepared for you today. Thank you for your time. Thank you for watching. As usually, if you have any questions, please write them in the comment section. I will be more than happy to help you. Of course, the link to the source code will be in the description of this video. And that's it. Thank you for your time. Thank you for watching, and see you next time. Bye.